to that example, doing it in Matlab. So look, if we can say it like this, that L1 represent length 1, which is 0.45, L2 represent 1.3, which is length of region 2, A1 represent area of length region 1, area A2 represent a length of area of region 2, UR represent relative permeability, which is given in the question, and that is 2500. U naught is basically 4 pi, which is constant permeability of a free space or a magnetic constant. Number of turns is 200. I is equal to 1. These are the data given. So we can, just like the problem which we solved theoretically, obviously we can say that R1, which is reluctance of 1, is equal to L1 divided by UR, which is this, into U naught into A1, right? So what it does, it gives a numerical value, right? You obviously, with the numerical value, normally with you need to have it in a form of a string or a form of a character. Basically, the advantage here it is, it would show as 1.48 multiplied 10 raised to the power minus something, right? I want to get an accurate number, which is quite a precise number, right? So for that number, what I normally do is I use a command called as number to string. Normally, whenever guys you are not sure about a command in your Matlab, just copy it and paste it in, let's say, in your Google. So let's say, I think you guys know that, so leave it. Or if you want me to, num to string Matlab, right? So this one. So it basically would explain each and everything of a particular command, right? So this command, the purpose of here, it is nothing but sorry, excuse me for that. So here basically is nothing but it converts the numbers to some string representation. If you want to make it a very precise, so you add string R1 comma precision, it will come as a precise value, right? So this is reluctance 2. Then you calculate the total reluctance, then find the magnetomotive force N into I. Then from the flux is nothing but magnetomotive force divided by total reluctance, and then find the display the flux value, right? So these are the results that comes out to be. Okay, let me quickly go through the Matlab, and these are different. Let's say we do it till here with F9, right? And now just let's say this one, let's take this value. So it comes out to be 1.4324 E plus means 10 raised to the power something, all right? Now if I'm explaining it this by converting it to this, it gives us the value, right? 1432, the exact value, right? The same would be here. Ultimately we come here, let's say we need to execute these commands as well. F9, R2 would also come as like this. Then flux would come out to be like this, right? So these are the results values, right? So it's a good way of doing like solving the problem, especially when it comes in the next lecture. Basically we'll be plotting some figures as well. The example contains some plots and you need to do the plotting. So this would help us, the Matlab, by executing it, it will gives us the variables, and just we have to plot X and Y, or Y over X or something like that, and it would immediately give us the plot, right? So this basically was the entire lecture. What I am expecting from you guys, which we'll be doing it in the next classes as well, is that the home task that you are going to take is do the example 1, 2 and 1, 3 of the same book, right? So you have, and it's easy, right? It's very easy. You just have to these two examples, right? So with the same answers, and you have to just show it to me that yes, it worked like this, right? And another very important thing, Hamza, especially for you, I've noticed that you guys are not serious in the class. Most of the people are not coming to class that regularly. So next week class, we'll have a very important class. I'll be taking quiz from next onwards, right? Quizzes from you guys, topics, right? So